fly through these really fast. If you look at worksheet 9B, that's what already has these notes on it. A constant function would just look like this. The identity function is the line y equals x. The quadratic is a parabola at the vertex. A cubic goes from the bottom left to the top right through the vertex. A square root would start at 0, 0 and go to the right. These are matching up what's on 9B, right? Hopefully. Tell me if I mess one up. The reciprocal function is got a branch in the positive, positive, and a branch in the negative, negative. Absolute value function is a V. This is the greatest integer. They use that little heavy bracket thing going on there, okay? And that one looks like this with open and then it jumps up, okay? And the cube root function we will also use, and Delta Math uses, and that looks like this, okay? So that was a quick review of those that we did the other day in the notes. Okay, top of 10A, is that right? I know it starts with number 2. Everybody find where we are? Is it 10A? Okay, thanks. So it says throughout the course, we will become more familiar with several transformations on the graph of a function. So the first exploration here gives us a quadratic function, and it wants to know what effect does h have. So h here, they have a -1, a +3, a -2, and a +1. Remember, the generic quadratic was through the origin. So -1 actually moved it what? Right 1. Okay, a +3 in here moved it left 3. Is everybody with me? You understand what we're doing here? So a -2 in here actually shifted it to the right 2. And a +1 shifted it left 1. So what effect does h have on the function? Anybody know what's that's called, the fancy name for shifting something left or right? It would be a horizontal transformation. Translation, sorry. Horizontal translation. I'm okay if you just say it shifted it left 2 or right 3, okay? I know there's teachers who make you say horizontal shift left or horizontal shift right, but and this is going to be a general concept over everything we do that has these inside of the parentheses. Anything that happens inside of the parentheses here to the x is going to be the opposite of what it seems, okay? So when we put a +3, it's actually left 3. When we put a ×2 in there, it's actually going to shrink something by 1/2. It's the opposite of what it seems. We'll revisit that idea as we go today. All right, these show an odd power function. So the initial function just looked like this. What did a +1 outside, not inside the function here, but on the back, what did that do? This shifted it up 1. This one shifted it down 3, down 2, and up 3. Okay, so what is that called? Does anybody know what that would be then? That K value on the back shifts, yeah, vertical translation. Shifts up or down. It is a vertical. And translation is the fancy word or slide that I'm okay if you never use, because translation and transformation just are too close in my brain. I say the wrong one when I mean transformation is all of these. Translation is slide, and I don't like that they're so close. All right. Question 4, this is an even root function, meaning the parent was just a square root coming out of the origin here. This is affecting, seeing what a does. So putting a positive, instead of going through 0, 0, 1, 1, and 4, the square root of 4 is 2. So this is what the normal one would look like. That 3 made it go through 1, 3. The 1/2 made it go through 1, 1/2. The -3 made it go through 1, -3. And the 1/4 out here made it go through 1, 1/4. So what effect does a have on the function? Does anybody know what that's called? The value, okay, this first asks what the sign, I gotta read better. What effect does the sign of a have on the function? If a is negative, what happens to the function? Anybody know? Yeah, it reflects, is called a reflection across which axis? Yes. All right. And the absolute value of a, which means ignoring the sign, what did a 3 versus a 1/2 do? Does anybody know what that would be called? Yes, it is a vertical stretch. Okay? It is stretching the graph up and down. It's hard to tell because there's not really points side to side, but it didn't change the point at the origin. It just is a vertical stretch or shrink. If a is greater than 1, the absolute value of a, ignoring the sign, if the number is more than 1, it's a stretch. What happened with the 1/2 or the 1/4? That is called a shrink or a compression. You're welcome to say shrink. I just find that eventually when we start talking, it's like somebody sat on it, right? It's compressed down towards the x-axis. And that's if it is a number between 0 and 1. So less than 1. If it's negative, that's a whole other issue. This is just talking about the value of a. Yes. Yes. I just want to make sure everybody understands that the negative is a separate concept. Good job, Jada. Okay. Is that it on that page? Okay. On the next page is just kind of a reference sheet that we're going to fill in. It talks about rigid versus non-rigid transformations. Not going to spend a lot of time on this, but rigid transformations, everything still is exactly the same size and shape. It might have just shifted, okay, or flipped. So a translation, a slide, or a reflection are rigid transformations. You might have learned this in geometry. Okay, when you distort the shape by some amount, it's a non-rigid transformation. It calls them dilations here, but it means stretches and shrinks. And it doesn't matter whether it's stretching or shrinking. The X or the Y, those are non-rigid. In other words, it's not the same size and shape when you're done. And I'm not going to ask you if it's rigid or non-rigid, but it's possible you could see that vocabulary on a standardized test or something. All right. This is a little confusing because it looks like it changed size, but it's not changing size. It just is cut off or shows more of the graph because it's slid up and down. Okay. If we just looked at this little piece, It is the same size in each of those. It just looks a little funky because it's slid up and down. All right. Translation as a shift. If you add, or I'm sorry, if you subtract something on the back, that is going to slide it down. If you add something on the back, that is going to slide it up. On the inside, it's wrong. So if you do left, what is it actually going to look like? It's going to be plus. And it's going to be minus if it goes to the right. Everybody good? All right. This is an explanation of why it does the opposite of what it seems. It says when functions are transformed on the outside, you move the function up and down and do the regular math. These are vertical transformations or translations and affect the y part of the function. When transformations are made on the inside, you move the function back and forth. But you do the opposite math, since if you were to isolate the x, you'd have to move everything to the other side, so it's the opposite operation, okay? It's just an explanation of why it's the opposite. All right, moving on, when we add a negative out front of the function, that reflects it across the x-axis. If you just remember, a parabola is an x squared, but a negative x squared means the parabola opens down, right? So multiplying a negative out front flips it over. When you reflect in the y-axis, which would be a left-right flip, okay, this was an up-down flip, up to down or down to up. That's supposed to say right. Okay, left to right or right to left, that is a reflection in the y-axis, and that would change the sign inside. Think about that for a minute. It's taking all your positive x's and making them negative, yes? Does that make sense? Okay. And this is taking f of x, remember, means y. So this is taking all your y values and flipping them down here. All right, another type of rigid, this is just a slide on the same thing, is a rigid transformation, is a reflection, which produces the mirror image across a particular line. If you put the negative out front, it flips down this way. If you put the negative inside, it flips left to right, because it's changing y or x values. I pretty much talked about that already. All right, this is a real struggle for students. When we start combining all of these things, students tend to think that the order doesn't matter in which you explain them or do them, but that's not true. You have to follow kind of an order of operations thing. In other words, if I'm looking, you don't have this one, but if I'm looking at this one, if I told you to put a 5 in here, what is the first thing you would do if I told you to put a 5 in for x? 5 minus 1, okay? Then after you took the square root, the next thing you would do is take the opposite of it, and the last thing you would do is add the 2. So that is the order in which you have to explain the transformations. So the minus 1 inside would shift it right 1. The negative out in the front on the whole thing here would reflect over the x. And the plus 2 at the end would shift it up 2. Okay? It's different than if you said that reflection last. Do you see where it ended up, guys? Ended up at 1, 2. Okay? If you said, I'm going to do that, I'm going to shift it right 1 and up 2 and then flip it, right 1 and up 2 and then flip it across the x-axis, it ends up down here at 1, negative 2. It matters the order you explain the transformations in is what I'm trying to get across here. So here's another slide on that. Can anybody tell me what order you would do these things in? Parentheses first. So what does a +2 do inside the parentheses? Left 2, right? Because the next thing you would do after you cubed it is do what? Multiply by the 3. And what is the multiplying by 3 doing? It is a vertical stretch, and we haven't spent a lot of time on that one yet. It's a vertical stretch by 3. And then the last thing you would do is this, which is slide it down 1. All right, we're going to talk more about stretches and compressions right now. A vertical compression means you are multiplying out front by a number less than 1. So a f of x, where this number is smaller than 1. So where a is between 0 and 1. Okay? Like a 1/2 f of x, if that will help you remember. A vertical stretch, I knew I had put those links in here somewhere. They're right there. Okay. A vertical stretch is a f of x, a times f of x, but the a is greater than 1. And I'm putting those absolute values because you ignore the sign on a. The function will compress or stretch vertically by a factor of whatever a is. So, if it's a 2, all the y values will multiply by 2. If it's a 1/2, all the y values will multiply by 1/2, but that will make them smaller. Everybody get that? All right, I have a gift for you. I spent some time, I think. So this is a function. This is my plain old f of x, okay? What do you think a 2 is going to do to that? A multiplied 2 onto the whole function. Stretch all the y values up 2. Everybody good? So if this was down at like -12, it's going to go down to -24 or something. If this was up, it does, okay, I'll show you what happens. It does not change the x-intercepts. Does everybody see that? It just changes the y values. If I put a 1/2, then it shrinks the y values by 1/2, but it does not change the x's. You guys are acting like this is sleepy time, but when you actually go to graph, these students have a horrible time with the difference between horizontal and vertical. Because what happens horizontally, and we'll put it in here in a minute, but what happens horizontally is very different. When you put a 2 inside on the function, it actually shrinks, and it shrinks x values. Look what happens, guys. Do you see the height is still the same? But where this was out at -4, it's now at -2, okay? Where this was over at 3, it's now at 1.5. If we do 1/2 inside, it stretches it horizontally. The y values stay the same. It's the same height. But where it was at -4, it now goes clear out to -8. And where it was over here at 3, it's now out at 6. It changes the x values by the opposite or the reciprocal power. Number, not power. Okay. So let's go back here and write a compression is inside, and it's when a is greater than 1. So f of ax, and a is greater than 1. So we'll compress by 1 over a. We'll compress or stretch by a factor of 1 over a. It's the reciprocal. A stretch is f of a when a is between 0 and 1. So let's do an example so that this makes sense. If you had f of 2x, it would be a compression. If you had f of 1/2 x, it would be a stretch by 2. It is the reciprocal that you use to stretch it or compress it. So this one had a 1/2 x for the compression and a 2x for the stretch, 2f of x. This is changing y values, and this is changing x values. And again, remember, anything inside the parentheses is the opposite of what it seems, okay? When it's inside, does the opposite of what it seems like it should do. How we doing? We need a candy break or we got this? Okay, one more time. If this was the parent function, okay, and I made it 2f of x, it would stretch vertically. If I made it 1/2 f of x, like the blue one there, it would compress vertically. If I took the same function and I made it f of 1/2 x, it would actually stretch horizontally. And if I took the same graph here and made it f of 2x, it would take this 3 and move it into 1.5. It would compress it horizontally. Those are my really bad sketches. Okay, that's why I use Desmos to find some more. So we're going to do this. Ready? What are we going to do to this? What two things are happening? Up 3. And the first we're supposed to reflect it over what? The y-axis. So reflect left to right. So I'm just going to show you left to right. If we reflect this, this was -3, 0. It's going to become +3, 0. These two, if we reflect, will stay the same. Okay, so it would look like this. This dot right here, if I reflect over the y, would be here. And if this one that was 1, 2, 3, 4 would be 4 this way. Okay, that is the f of -x. What do we still have to do to that though? Yeah, and so maybe you want to draw it on this one, I don't know, and then show that you're shifting it up, because if you keep drawing on that first one, you're going to have a mess. Okay, so this is the reflected one. Okay, I should have drawn it there, sorry. And then we still have to finish by moving it up 3. So all of those dots move up exactly 3. Now it should be exactly the same size and shape, but it has flipped left to right and slid up 3. Because one was a horizontal flip and one was a vertical, it wouldn't have mattered which we did first, it would be the same on that one. All right, we have 2 f of x plus 1. I'll do the first one in blue. Which is the first thing we need to do? Okay, if I told you 2x plus 1 and I said put in an x equals 6, what would you do first to it? Order of operations, say you would add the 1 and then multiply by the 2, yes? So that's the order you have to tell me. Add the 1. Well, adding 1 in a function actually shifts it what? Left 1. Horizontal shift left 1. And then the 2 is going to do what? A vertical stretch by 2. Okay, so I'm going to shift everything left 1 first. Should be the same size and shape until we do the stretch. Everybody good? What does the stretch do again? A vertical stretch multiplies all the y values, in this case by 2. Well, this guy's negative 4, 0. Multiplying 0 by 2 does nothing, right? But this guy's at negative 2, 2, so it's got to go up to negative 2 what? Is anybody following here? The y value is double. This dot right here is at 0, 2. When I double it, yes, because I moved it left. Okay, it's at 0, 2. When I double it, it's now at 0, 4. But what happens with this dot down here? This is at 1, negative 2, so it's going to go to 1, negative 4. And I won't be able to draw that line straight. I'll go all the way down there. Stretching it vertically changed all the y values. It's twice as tall away from the x-axis. Everybody got it? It shifted left and then stretched. All right, this one does what two things? This one, the order matters, okay? The negative out front changes the y values. It flips or reflects over the x, or up, down. It's going to reflect this way, top to bottom. And then the second thing it's going to do, what's a +2 on the back do? Vertical shift up 2. Now, let me just show you something real fast. If you did the shift up 2 first, that's what it would look like, roughly, okay? And then when you flipped it over, it would be right there. But we're supposed to flip it over first. Was I doing blue for the first one, guys? Okay, so flip it over first. This was 2, -2. It's now going to be 2, +2. Okay, so there's the flip it over part. And then I'm supposed to do what? Move it up 2. So this point moves up 2, this point moves up 2, this point moves up 2, this point moves up 2. So both of those things had to do with y values. It flipped upside down and it shifted up. Do you understand, guys, that if I shifted up and then reflected, it's not the same graph, right? Okay. How we doing? All right, we're supposed to write these. Can anybody help me? How do I put a up 7 on that? Where does it go? Yes. So y equals absolute value of x and then a plus 7 on the back. How do I go left 3 though? Plus 3 inside. And in this case, it's inside the absolute value. This just takes some practice because it's hard to know what inside and outside means. But this one, we're going to put like parentheses around the x, and inside would be inside of those parentheses, okay? Reflect over x. Now, x goes this way, so reflecting changes y values. So where does the negative go? Yeah, it's going to change the entire function. For parabola, it actually doesn't matter, but it is going to be upside down. You could skip those parentheses and it's the same thing. Right 9 though, where's right 9? In the parentheses, and it's what kind of, so you do need parentheses, I lied. Right 9 is minus. All right, again, this is the idea, okay? So you're not confused. Down 2 goes where? Goes on the back. Reflect over x. Ooh, this is a trick. If they want us to do down 2 and then reflect over x, we would need to say, now I'm going to reflect over x. That's a tricky one. Put the negative on the outside. And then a vertical shrink of 1/6 would also be on the front. Yeah, I don't like that question. That's why it has a star. So you'd actually have a negative 1/6 and then an x squared minus 2. I won't ask that, I promise, okay? Right 6 and a vertical shrink of 2. The order doesn't matter there, okay? Vertical stretch of 2, thank you. So this one is not, I don't know why it started, it's not hard. How do you go right 6? Inside or outside? Inside, and it's a what? -6. And a vertical stretch of 2 is just a multiplied 2. Okay, number 4. Uck, not ever asking you that. Order, at least that order. All right. What? Go ahead. Someone have a question? Yes. It wouldn't matter, yeah. Did someone else have a question? Just pretend we didn't do that one, okay? I didn't mean to confuse you. Down, vertical shift, horizontal, vertical stretch. Right 4. The order doesn't matter here, it's the reflections. So we can just do this any order we want, but Down 6 is what, guys? On the back, we'd have a minus 6. A vertical stretch of 5 would be, yeah, a 5 on the function here. And right 4 would be plus 4. No, minus 4. Let me fix myself. Where's the vertex of this? We already did vertex form, right? Opposite of this and this. So the vertex is at 4, negative 6. Is that right 4 and down 6? Okay. And the 5 just stretched it. Reflect over x. Okay, that's going to be out front of the function. And then up to and left 9. Those are the two that have to happen in this order. Left 9 would be a plus 9 inside. But as long as this reflecting happens before the up, we're okay. Is it going to happen before the up right now because of order of operations? Yes. That we would actually do the left 9 first, but that wouldn't matter. Okay. Whew, that was painful. All right. How much time we got left? Okay. I would like you to see if you can, we'll do this as a warm-up tomorrow, but right now I'd like you to spend the next 3 minutes seeing if you can figure out any of these matching ones on this page. Okay? Ones you might be able to figure out pretty easily. What are those two doing? Number 1 and number 6 are a basic shift down or to the right. A lot of the other ones are tricky because they have 2 things going on. Number 3 isn't awful. What are the 2 things going on number 3? What's a plus 2 do inside? Left 2, and the negative on the outside would be upside down. Yes. Number 6? Number 6 just says move it right 2. It's going to look exactly like this, move to the right 2. So all of those points when they move to the right 2, it's probably cut off on the graph because it's like that for number 6. Okay, I am going to show you the assignment, and it is all tonight on Delta Math, okay? $1.5B on Delta Math.